Let's talk about minimizing consumption in your cooling systems, specifically how to reduce water consumption. Hi, my name is Anthony Rowan. I'm the COO of Capture H2O, and we're going to dive a little bit more into how we can raise your cycles of concentration to lower your cooling tower water consumption. So all water, whether it's in your pool, the ocean, or your cooling tower, has some amount of minerals in it. And how we measure the concentration of minerals is the total dissolved solids concentration, or TDS.
There's two types of water in a cooling system. You've got your makeup water and you've got your cooling water. Makeup water equals the amount of water evaporated from the system plus the amount of water blown down to the drain. Let's start with a hypothetical. If you've got a cup of water with 200 parts of minerals in it and you leave it outside and half that water evaporates, remember, evaporation is pure water leaving the system, then you've got 200 parts of minerals in half the amount of water. If I then go in and fill that cup of water with the same water we started with, I've got 400 parts of minerals in that water, but the same amount of water we started with. This is the same concept of cycles of concentration.
If my cup is twice as concentrated TDS as the water I'm filling it up with again, that means my cup of water is at 2 cycles of concentration.
This is the exact same thing that's happening in a cooling tower. When you have water evaporating from the cooling tower, the minerals are accumulating in the basin of the tower. To figure out the amount of water being blown down versus being evaporated, we take the inverse of the cycles of concentration. So in our example, we have 2 cycles of concentration. If we take the inverse of that number, that's 1 divided by 2, or 50% blowdown and 50% evaporation. Now remember that evaporation is constant because of the heat load on the system. So the way for us to save water is by minimizing the amount of blowdown. We do this by increasing cycles of concentration. Notice that each increased cycle of concentration leads to diminishing returns. We save a lot of water going from 2 cycles, or 50% blowdown, to 3 cycles, or 33% blowdown. But we save less going from 10 cycles, or 10% blowdown, to 20 cycles, which is 5% blowdown.
So getting as many cycles of concentration as possible while still maintaining control and minimizing consumption of other items will ultimately help you achieve your water conservation goals. What's important to know is many cooling water treatment programs are generally limited on how many cycles they can operate at. And if you want to learn more about what those limiting factors are, please visit CaptureH2O.com and download our Cooling Water Savings 101 white paper to learn more.